Hello, all. Welcome back once again to another Fusion Friday, Free Support Friday. That being said, I am your host, as always, Fusion Phil over here at jitcadcam. If you guys don't know me, I am an Autodesk reseller for Autodesk Fusion, as well as other Autodesk products. And every Friday, we are hosting free support for each and every one of you. So feel free to put questions in the chat, as you guys are going to see. I'm going to give this a few minutes as this warms up. I also need to adjust my camera here real quick. It's a little dark in the background. I know we've had tons of technical difficulties over the last couple of weeks, and maybe this week, we'll strive to actually have a really good week starting off. So I can see I just got the notification on my phone that we are live. For all of you out there, go ahead and let me know if I sound all right. Make sure my video is coming through clear. Everything's looking good. With that, though, kind of a funny thing. I think most of you guys are used to me looking more this way when utilizing, obviously, my video. But I realized over the last, year that I've been doing this, not only have we reached finally 1,600 subscribers, but I've actually been backwards. So you guys should be able to read my name now on my actual shirt, jitcadcam. And with that, I've got my audio changed up. I've got my video set now. We're going to give this a few more minutes to see for my stats to pull through so I can see who's out there watching, obviously. And with that, we can also kick this off. So if you guys have any questions at all, feel free to put them in the chat. I'm happy to cover different subjects. So again, we'll give this a few more minutes. I don't know why my system is registering. I know we're 2 minutes into this intro. It's another Friday. Hopefully it's a really good Friday. It's actually possibly one of my most absolute favorite Fridays, and we'll talk about that a little bit further. So it looks like we got already a question in the chat. Speeds and feeds question. Deep versus shallow. Seems full depth helps end mill life. Yeah, no problem. Yeah, I mean, we could definitely dive into that. I could show you a couple different scenarios. There we go. We got my stats coming through. I can see you guys all in there, live viewers currently, everybody watching. But yeah, let's dive into that question that TC Alpha has. I'm going to go ahead and pop over in Fusion. Now, this is your official warning. I know everybody out there, I see this every week that it happens, every time they do maintenance. You do have this lovely banner. So for all of you out there, Saturday from 10 a.m. to 1, that's Central Standard Time based on my Fusion seat, Fusion will have maintenance. So if your Fusion isn't working, you can now say by watching this video, you know why. And if you're like me, you usually go in here and just hit the X and don't think about it at all. But let's go ahead and pop open a part and look at a couple of scenarios that would have both of those at use. So in short, it really is going to come down to what kind of actual tooling you're using. So I'm trying to think here. Actually, I know a really good part we can use. So let's go ahead and jump back. I got to remember where it's at because it's been a minute. I think I pulled it up last week nonetheless. But let's see here. You look at these files every once in a while and then you forget that you have them. Where did we have that? Maybe I'll just do the good old-fashioned Fusion search. How's everybody's Friday going otherwise? So as you were asking, let's go ahead and get Machine Sim turned off here. But from a standpoint, I assume you're talking about roughing, or you seem to be talking more about finishing at the end of the day. If you want to go ahead and pop that in chat real quick while I get this file cleaned up. Roughing? Okay. So actually, I have a video I'm going to be making here soon talking about the difference between roughing, but to give you a crash course and an idea of the difference between basically using the full width of the cutter versus using the full length of the cutter is I'm going to show you in the differences between adaptive clearing and pocket clearing. So on a part like this, it's not realistic to use adaptive clearing. And I would say in a lot of cases, you're going to make this decision based on your part. But let's just say for some reason, we bought a 1-inch flat end mill and we want to rough out this mold. Now, what's going to happen is we're going to engage a certain depth of cut and a certain amount of step over. Now, we can control that at the tool level while this calculates. Now, a good way to think about this is I like to make things mentally comparable, right? So if you've ever cut your grass and you used a lawnmower versus a weed whacker, what you kind of understand is the same concept here when we use pocket clearing versus adaptive clearing, right? So in the case of aluminum roughing, when this tool was set up, we have a 1.125 step down, and then we're doing a 0.37 step over, or percentage-wise, this is about 40% step over. This is pretty common when working with aluminum. Now, the volume of material removal may or may not be more or less. However, what you're going to find out is when doing adaptive clearing, you never really use the full width of the cutter, of course. You're always going to keep it under 50%, but you're going to need a lot more torque, right? So if some of you are old manual machinists that worked on a Bridgeport like yours truly did, there's a reason why we conventionally mill versus climb milling, right? So the whole idea, actually, we climb mill now versus conventional milling because the amount of torque that it actually takes for that tool to get a bite in deep material going to the thinning side of it. But as you're going to see, again, we're not going to make any changes here. We're now doing our 1.1 depth of cut, always doing a 40% step over. Now that's going to require quite a bit of torque, which is going to require me to either slow down my feed rate or increase my spindle RPM, which I could be in danger of getting too high and getting out of my torque curve. Now, more commonly, this was a traditional approach. It still works well, obviously, on your thinner parts and things of that nature. But what I would look at is on a part like this, if we look more into pocket clearing, I'm going to go ahead and swap out this tool. We're going to keep with the 1-inch tool kind of idea, but I am going to go with a bowl end mill this time. And what we're going to do is we are actually going to copy this, and then we will be making a quick change to it. And the idea is if you've ever used a high feed mill, a high feed mill is going to come more with that idea of your flute length being closer to like 0.375, or if you're using an insert mill, and then you're going to have a corner radius on that if the idea is you're going to remove a lot of material. So I'm actually going to bump this up to about 60 thou. And what that is going to allow me to do is I would switch more to possibly aluminum slotting. But the idea is we're going to use a lot less torque in this case for us to go through and rough out this part. I'm actually going to swap out that aluminum roughing. And the reason is because this is going to give us a very large maximum step down. So let's go back to 100 thou step downs. And we may have to turn off rest machining because it's on by default. But as you're going to see here is we're going to be able to go in and rough out this part. But what's happening is this is much more comparable to a mower deck, right? So the idea is that because you're taking shallow step downs, you can take a much wider step over. And in theory, although your volume of removal is less, because we're only going, in this case, probably 0.95 step over and 100 thou step downs, it's less material, but it's also less torque at the end of the day. Which usually what would happen is you could go into something like this, and instead of running, in this case, 125 inches per minute, we could be looking at closer to 300 to 400 inches per minute when you're roughing something out. Now, again, this is required based on what your machine is capable of and things of that nature. I don't personally think one is right or wrong. I know in the world of machining, most machines wouldn't be able to handle a 1-inch cutter as well as you would think because they lack torque. Now, some of you are on some pretty big machines out there, of course, but as you can see, the pocket clearing side of things, again, it's less torque on the machine. You can feed it much faster, and you can make up time in speed. Again, it's a case-by-case scenario, in my opinion, TC. Hopefully that answers your question. And for all of you other ones out there that are starting to jump in and see what's going on, feel free to ask any questions you have at any time. I'm going to go ahead and start this off because you guys always buy me beers. And of course, maybe I got to put my hand in front of it. Yeah, the green screen behind me is covering up the can. I'm not going to drink a beer on stream as much as you guys like, but I do have a purpose for all those beers this weekend because it is Veterans Day. But I am going to enjoy this energy drink that I do purchase with some of that money from time to time. And seeing how we don't have any other questions really populating, I did get a couple questions throughout the week that people wanted to see or they were curious about. So let's go ahead and dive into some of that stuff and see what we're working with. So one of the first questions that I encountered came from a very good friend of mine, and he is one of my customers nonetheless, is Wes Collins, he works for Neighborhood Brake Center and makes headers for anything and everything, I think, at the end of the day. But what he was curious about is on his part, he has this lovely header flange, is that the size of the actual exhaust tubing on this flange needs to be modified. These actually are much too large of ports, or in this case, the actual oval piping that he's going to put in, these are 2.25 ports, and he wants to do the 1875 ports. So what we're going to do is we're going to walk through how to actually modify this model, and then we can see how to actually program this up in CAM on the backside. So the first thing I would do is, one, this part was never essentially designed in Fusion, which means we don't have a timeline at all. So what I'm going to do is I'm actually going to turn on my timeline, because this is a very important step for you to be able to go in and make your changes. And then from there, we're going to go ahead and populate a sketch right on top of our part. Now, little pro tip here is you can hit F6 since we're not near the origin, and I can snap back to wherever I need to be. But I know the port size, so what I need to do is I need to recreate what is going to be referred to as a slot drawing here. So let's go ahead and do a straight line, and we're going to do a construction line. And as I'm told by Wes himself, these ports always stay on the same center location. So I actually am going kitty corner here. And then from there, we're going to switch things up. We're going to go in for a slot. And what I'm going to do is I'm going to do a center point slot. And then with that, we'll turn our construction line back off, grab my midpoint, drag up a small distance, and then drag out. So now we can go through and we can dimension this. So I know this port is going to be 1.5 wide. And then with that, we need to actually set our dimension in the length to be able to create this. So what I'm going to do is I'm going to do D for dimension again. And now one neat thing is I can actually pick that sketch arc. And then if I click and hold, if I remember how to do this, we're going to go down to the other one, and I'm going to click and hold. And what you're going to notice initially is we're pulling center point to center point, right? So if I don't want to go center point to center point, what I'm going to do is I'm going to dimension again. And what I'm going to do is right click on that circle edge. And I'm going to say pick arc tangent. And then I'm going to go to my lower one again, pick arc tangent. And we'll have to do this one more time. Let's go ahead and pick our second one. And as you're seeing, we're now getting that length of that port based on the tangent edge of the actual arc or circle. So instead of going center to center, that right click has allowed us to pick the actual tangent face. So again, we're going to go in and we're going to put 2.20. TC, I see you out there in chat. Mind blown, right? It's little tricks like this that people don't know until they watch my video. And just like that, we have now created, let's drag this dimension up, the 1.5 wide by 2.2 long port on this actual sketch. And now, based on this information, what I'm going to do is I'm actually going to just do an extrude. So we're going to finish our sketch. We're going to grab that outside boundary. And then I'm just going to rotate my part over and click the backside. And what you're going to notice is we're now initially cutting that profile. I don't want to cut that profile. What I want to do is I want to do a join. And what you're going to see now is we've actually shrunk down that port in comparison to the other one. So the last thing I would need to do is go ahead and finish this up. And we're going to go in and we're going to throw in a chamfer on both of our edges, and whatever that chamfer is, or however they plan to actually set that up. So again, as you can see, I've only did one of the ports here. I could actually go through and do all of the ports down my part. But as you're seeing, again, we could have did that based on a sketch and replicated that down, keeping our timeline just in case. And this is in case of what Wes has going on. I know from time to time, he's actually asked me when I've helped him with these drawings, is I don't want it to be 2.20. I would actually like to go to 221. And that's because that gives that opening just a little bit more room for that tubing that is not precise to be stuck into a precise hole. So again, on our width here, I'm going to go ahead and add an extra 10. And just like that, we've now opened that up. And because of our timeline being linear, everything has come through automatically and adjusted my chamfer on the backside. So what I'm going to do is I'm going to go ahead and switch back over to manufacture. In this case, we've actually already created toolpaths on this part. And that's what Wes had me work with him in the past. And then in this case, we're going to actually cause some collisions here in the or not collisions, but errors. And those errors is because he actually likes to go in and pre-drill the center of these arcs. So again, because we removed or added new faces, we have to redefine those faces when working. And as you can see, again, you have that ability to do things automatically. Now, I did see a mistake here on Wes's part. I see him in chat, Wes. Shout out to you, man. Is he did see, oh, nope, he did select same size diameter. Awesome. So when you go through and select stuff like this, you could actually pick one arc and then it automatically finds all the other arcs or cylinders. So as you can see, within 3 mouse clicks and having select same size diameter turned on, I've been able to actually go through and pre-drill everything. So Wes, I see you out there. If you need to, you can always reach out to me, but you can see by creating that sketch, you could just, on a part like this, simply do that ×4 and make your life a dream. Again, he's got his roughing cycles all defined here. We're going to see that roughing come in. He's got his inside roughing also. Again, we get that error because we need to update the model. And then he would have his finishing strategies as well to clean everything up the rest of the way. Now, here's another trick for anybody out there watching is instead of actually picking edges here, as you guys are seeing, is one neat thing is he could actually go in and say a silhouette, and then you can define, do you want to do all loops or strictly outside or strictly inside of your part? So instead of me actually going out and having to pick edges, part edges, as I like to say, is I could use the silhouette feature to automatically define everything. So this is a neat thing at the end of the day that I know Wes did this part and he did a traditional edge approach, but had he gone in and actually said, let's do a silhouette, and with that silhouette, you're going to notice as we went from 2 different adaptive clearings to 1 adaptive clearing, but I believe he had some technical things that he was doing. And if I had to guess right, he's going all the way through the middle sections. So again, prepping him for the ability to actually do this in a quick fashion, we could say inner loops on this actual profile. And then on the other one, we could swap this out. And instead of doing a silhouette all, we do outer loops only. So as you're seeing is instead of me picking edges in 2D, which I'm not a fan of, I could actually take the information that he's using and automatically define things based on a silhouette of my physical part, and then using that silhouette either inside, outside, or both. Now, let's go back, and I'm going to show you guys a couple more tricks on this design while we wait for a few more questions. And I'm going to go back to that sketch. And as you guys have already seen, we went ahead and created that sketch on this first area. So this time round again, I'm going to go ahead and just actually, instead of doing it with the construction line and everything, I am going to go through and we are going to guesstimate this. So this is going to be a little different approach. We've already defined our first slot. So what I'm going to do is I'm going to just roughly draw my second one, and I'm going to use constraints to make this work. So we're going to go ahead and say equal flat to flat. And then from there, we can equal arc to arc. And now you can see I've created that port duplicated off the first port. Now, with a horizontal vertical, we can align this horizontally to one another. And then the last thing I would do is if I knew the spacing based on this part, I could go through and do my port spacing, which in this case is 4.9. Again, placing that next slot. Again, I say slot in this scenario because that is the tool being used in the sketch environment. But what that tool is allowing me to do is to recreate the second one based off that actual first one. Now, another thing you could do, Wes, is knowing that everything is 4.9, we could actually take that first sketch using control and highlight everything, and then we could create a rectangle pattern. And as you can see, I could drag this out, and we could do based on spacing, knowing that spacing is negative 4.9, and you want 4 of them total, I could very quickly do it this way as well. So again, kind of a neat, different approach depending on how you're looking at this. Now, whatever way you guys choose to do this, you're going to have a different approach when it comes to the extruding, as you saw me do before. So as I'm doing now, I'm holding control. I'm picking that outer donut on each one of these, and I'm hitting OK. And then I would need to go back to my design again. We're going to go ahead and use our chamfer tool. And then I'm going to hold control again, grab all those hard edges to throw chamfers on everything. And the real power of this just multiplies because now I think you all see the big picture here. where under manufacture, remember how we did silhouette? What I'm doing here is I'm going through and I can easily take any one of my toolpaths and regenerate them. And what that will automatically do again is go out and see outside silhouette, inside silhouette. And now on the drilling side of things, we did already set that first one. And because we did a pattern, we get that error because we are lacking one of those faces, right? So keep in mind those other 3 ports have all changed to the first one. So we only have 2 faces, the through hole and the center drilling on the corner, allowing everything to happen automatically. So Wes, I hope this helps a ton. I'm gonna go ahead and jump back in. Let's check out the chat and see what's going on. So I see Ash Designs. So have you ever dealt with starting a part where you need to leave extra material for rigidity? I remember this. For example, techniques like window machining, tabbing. Yes, I have. So I'll go ahead and draw something up with tabbing like you're thinking, and then we can walk through something like that. Rough out the first section, finish it, work your way down. Yep. Awesome. And then Deep Thinker, what do we got? I'm waiting for Fusion to finish loading so I can find a part that would be decent casting reference. Yeah, so I remember about that. 100% Deep Thinker. I'm more than happy to cover that casting question today. I actually like castings a lot because it's a lot less machining usually. But let's look at what Ash Designs was talking about. So in the case of what he's asking is, let's go ahead and find a part that would be a good candidate. I have one in mind. And what that one would be, I'm trying to remember where it's located. Here it is. This will be a good one. I need to come in here and steal the part out of here. So give me a quick second. For all of you in chat and all of you guys watching, feel free at any time to ask any questions you may have. And we're going to go ahead and take this part and let's go throw it back into our other folder. There we go. And now we can get that opened up. So I always like using parts like this because everybody thinks they're cool parts, right? So his question is let's say I need to manufacture this part. Well, the first thing I would not do, and this is a rule that everybody should make very, very clear to you guys. You should buy always. You're going to deal with jigs and fixtures in Fusion. You're not just machining this model. We need to think in assemblies, right? So as you guys see here, this body is at the top level of my components in my design tree. So we get this one cube, right? So this is a single component with all this design history stuck in this. So if I was to machine something and I needed to build a window or add vices, the very first thing I would do is I would start a new design, and we're going to go ahead and save this, and I'm going to call it window machining. So with that window machining, now you can design your jig first. Usually it's a little tricky until you bring in your part, right? So what I'm going to do is I'm now going to bring in this part. And with that part brought in, we can now go about whatever our machining strategy is going to be. So using a new component now, this is going to be basically my jig or whatever you plan to call this for your manufacturing. And what I would do is then start my sketch. And in this case, we were talking about window machining. So what I would do is I would draw my window. Again, I'm going to do this real rough for you guys so we can make sure we can keep these questions coming through. But the idea is I am now constructing my jig or however I plan to use this jig. So in this case, let's say I want it yay thickness. Again, keeping with that mindset that I need this to be the same size, if not bigger than the part I'm machining. And one thing I did forget, so we can go back, is adding things like tabs, right? So I'm going to model tabs. And what you're going to see me do with these tabs, I am lucking out because this part sits very well within the confines and on center of everything I do. So if I wanted to build this part, I'm going to go ahead and use that window method. I'm going to do a second extrude here. In this case, the correct way to do this would have been symmetrical the first time round. And now you can see I kind of have my tabs floating in space. or wherever I want to put those tabs. Let's go ahead and move this one down. You guys didn't know you can actually move your sketches around without being in your sketch. So if you're like me and you like to estimate or guess to where to put stuff, you can actually leave that sketch on and drag these lines and arcs around, moving that on the fly. So as you can see, I now have my part and then I have my jig to work with. This jig is technically going to be modeling for machining, right? And I actually did a video about this where you have the ability to go in and actually design jigs and fixtures with this idea. But we're going to go in, we're going to do our milling, our model for manufacturing, and this is where you need to make this decision. I cannot make this decision for you. There's a case for each one. And as my workflow Wednesday showed is this the model you want to be machining the entire way through? Or do you only want to use this for certain scenarios? Well, in the case of this part, we're actually going to want to come in and cut these tabs at the end. So what I'm not going to do is I'm not going to put this model as part of my actual model in my setup. We're going to use model in our toolpath for this. Now, one thing cool about that, though, is we now have fixtures. So since I made that video, we could define this as a fixture, but you do need to be aware fixtures now have their own clearance setting. So I'm going to go ahead and throw in 50 thou because I'm more than comfortable for getting within 50 of my fixture. Now, knowing that this fixture is going to be able to be machined later or something like that, you may not want to define it as a fixture, as funny as it is, because it would cause collisions, right? I'm just going to show you guys the power of Fusion where we go in. We now start our process of machining. As you all know, we're going to go hunt down that lovely 1/2-inch flat end mill that I love to use. Now, in the case of this is we could do a machining boundary and we could say, I want to stay within this rectangle that we drew. Tool stays inside of that boundary. And then away you go with all of your machining. Now, keep in mind, my tool is pointed the wrong way because yours truly is moving a little quick here and we're trying to get a very quick result. But as you can see now is we'll do our machining horizontally. And because of our jig and fixture avoidance and all of that, we should see that populate through in that toolpath. Now, keep in mind, my stock is currently turned on, so we need to go back and redefine my stock. That's why we're seeing a small toolpath for machining. So if we go back, maybe our stock, and this is where everything gets crazy, fixed size box, maybe it is 12 by, what would that be tall? Probably about 9. And as you can see, now my stock is roughly the size of my jig. And again, we regenerate our toolpath. Any questions about this as we work through this? I'm seeing more and more people come and go. If you guys have questions, feel free to reach out to at any time. So again, now you can see because we're using tool containment, we're staying inside of that window. We've roughed, we've finished our part. We can come back and do something along the lines of cutting those tabs. So again, we're actually all going to learn this together here today. Is I'm going to be curious. I think it's going to cause us a collision when we come in and try to machine this. And we're going to go lowest of selected. And we want to go model bottom, possibly past that minus 0.02. And as you're seeing, in the case of 2D contour, it goes straight through our jig with no problems. But as you can see, that would be me machining off that actual tab to be able to drop my part out. Now, again, keep in mind, this is where I think there's an advantage and a disadvantage. So by not defining that as my fixture, I can go through, again, using that sketch for my geometry and using those bodies to avoid, because at my adaptive clearing setup, my geometry, I can turn on model. And then for this specific toolpath, I would really like to actually use that jig that we designed to be included in my setup for avoidance. Again, this is where you play that game. Do you use model at the individual tool level? Do you use model at your setup? Knowing that we actually are going to machine across that part at some point, I wouldn't put it in my setup. I would bring it through my different actual toolpaths on a need-to-use basis. Hopefully that answers kind of the question of window machining and helping you get a little better idea on how to do that and how to approach that for cutting those parts off. Now, some of you may be wondering why on my tab it doesn't cut all the way across. Well, Fusion Sim is showing you only where the flutes make contact. So I would need to edit my tool real quick and make this adjustment. So length below holder is probably 2 inches. And with that, we want to go ahead and say our flute length is closer to 2 inches. Oh, there we go. I am hitting F1 and F2, guys. I'm not hitting 2. That's kind of week I've had. So let's go ahead and hit accept now. Oh, shoulder length. Go ahead and bump that up. The luxury of a smart software makes me look like a fool sometimes. But again, as you can see, not a crazy hard thing to do. I know I ran through that a little quick, but the idea of actually utilizing a secondary body in the background and designing your own manual tabs here, there, and everywhere. Now, if you were using 2D toolpaths, again, you have that ability in certain toolpaths to turn on what's called tabs, but that's only in 2D contour, right? You can't go through TD or 3D toolpaths and turn on tabs. That's why I actually modeled the idea of where you would have those windows or those tabs at. Same thing with, like we said, is coming back and cutting those tabs. Now you can see that goes all the way through that green stock, right? So that's how I would machine apart, you know, this side, that side, and then break it out, and away we would go. For anybody that's just joined, guys, yes, I know you would not do this part this way. I completely agree, right? You would probably do 1 or 2 tabs down here on the bottom, like when I show it in the video walking people through this. So let's see what do we have for other questions out there. So best approach for holding lower to mill out the forbidden pocket. That's a good question. Well, it depends on your lower. I'm not going to say much on that subject because it might get me in trouble. But if you have flat faces horizontal to each other, you actually luck out quite good, where just a normal machining 6-inch vise would do wonders for you. If it's more complex than that, you may need to make a negative off the side profiles of this and utilize that at the end of the day. The smoothing, all right, let's see. The smoothing at a lot more lines in a program. For an example, let's say geodesic. A little hard to read. Oh, I think I know what you're talking about. Okay, smoothing. You had questions about smoothing earlier. You're messaging me on Facebook. So, smoothing as a whole. I always like the conversation about smoothing, right? So, I'm going to run back to this mold cavity real quick, and we're going to swap out our setup because our stock in this case, much easier to simulate this and see it cleanly, is just going to be the part we're machining on. So when using different tool paths, you do have different options for smoothing. And his question is about geodesic. So we're going to go ahead and give this tool path a surface. And I'm going to go out and grab a tool as a 1/2-inch ball end mill. And as always, you guys, I should probably get shirts that say this. When in doubt, okay your way out. You know, it's more important to get a path on the part than usually it is to get the correct path on the part first time round, right? We're not hand coding at the machine anymore. We can regenerate tool paths till the end of time. So as you're going to see here, I'm going to turn on points down here at the bottom of my screen, making it much easier to see how these points are going to interact or what they're going to machine and what they're not going to machine. Now, I am going to adjust my setup one more time to give you guys a few more points, because if I remember correctly, we did some stuff with this video. We actually used this part on Workflow Wednesday for showing why you would use model that we just talked about, right? So now we should see this tool path that's going to dip down inside of these holes a little bit more and things like that. So your Haas does not have high-speed machining. Yeah, so if you're somebody really looking to make a difference on your tool paths and hopefully speed them up because your machine lacks look ahead or you don't actually have smoothing at the controller, using smoothing in Fusion can make a big difference. So what I always tell people is what you do is you expand your tool path out to really see the full outcome. And we're going to duplicate this tool path. And then I'm going to edit the second tool path. And what I'm going to do is I'm going to turn on smoothing by default. And we're just going to hit OK. And we're going to check our results. So what smoothing is designed to do is to basically reduce your points based on a certain amount of area. Now, what you're seeing here for smoothing on geodesic is a little bit different. And the reason why it's different is because it's not smoothing based on the top, like how much you're allowing a point to move to get it in line with the other points, right? What we're actually doing is saying how far away can one point be from the next point, right? Normally you're trying to reduce points. And if you wanted to reduce points, you would actually have to turn up your smoothing here dramatic amounts, because again, it's based on a spacing scenario. It's not actually based on the traditional approach. If we went in here with a scallop toolpath, give me a quick second here, and we'll see on the scallop toolpath, you'll see, again, we'll get a bunch of points based on machining this top surface. Again, a lot of points, right? And looking at the data on this, when we duplicate this and we go in and turn on smoothing this time, smoothing is going to have its own tolerance. Now, what you're doing with smoothing is, like I said, is we're allowing, basically the concept would be is what points can we move a certain amount to get rid of them? This is the amount we're allowing them to fluctuate to smooth out those arcs, right? So by turning it on by default, matching it to our tolerance right off the rip, as you guys see, we've reduced this file a ton. And by a ton, by almost 80% it looks like. So that simple checkbox of smoothing has allowed us less points. Less points on an older machine or a machine lacking look ahead will actually speed up your toolpath more than most people think. So even though your machine could go 100 inches per minute, it's going stop sign to stop sign. It's not like you're going, 100 inches per minute, almost like a freeway where there is no stop sign, right? Gert, I hope that answers your question, and I hope you're saying your name right. Because there is other smoothing outside of that. If you were to ever purchase Steep and Shallow has some wild smoothing in here as well. The smoothing on Steep and Shallow, again, you're seeing that idea of evenly spaced points versus fit the arcs, right? So you could actually reduce the points in an arc dramatically because we want to actually put them into one arc versus multiple little segments. Cool. With that, guys, I see a lot more people coming in here. If you guys have any questions at any time, feel free to throw them up in chat. I've also figured out how to put the Discord link down below so it never expires. I may have to change it at some point due to some people, you never know what's going to happen. You guys can join us on Discord. You can send me messages directly via my actual support email down below. It'll create a ticket automatically. And I'm more than happy to help you with anything you have or any questions you may have. So I'm going to go ahead and skim the old support system here real quick. Take a glance at Discord. And let's get back over here and see if we have any more questions from anybody. Oh, looks like we got another question that came in. In the container method, I have a love-hate relationship with the old container method. It really depends on the part I'm doing, Ash. To me, it's if I'm doing a part, and I say a part with a work offset, it's very easy to go out and pattern my work offset versus patterning my parts. Now, I prefer each one of my part, maybe not on a setup one. I have a customer, maybe I'll see if he'll allow me to put it up, but me personally, if I'm patterning, if I'm using a tombstone and it's the same part 4 times around, like things like that, my first setup, given that I'm using usually a stop and a simple square piece of material, I usually keep that with the concept that it's one work offset if it's easier for me to do. I have a lot of customers that run, 100 parts off one work offset, and then I know people that run 100 work offsets, right? So me personally, until Autodesk figures out how to do, what would it be? It'd be basically like fixtures or a way to bring in my G code from an external file with the part and set it up on like a tombstone. I think the best way for me is I always do one part. I may model my entire assembly, but I would still do one part, multiple work offsets, and then that one part actually goes into my second, third, fourth setup. That way I can actually use continuous rest machining, right? So if you guys didn't know, unless they fixed it since I last knew about it, is based on what we're doing, you do have from preceding setup And now the best way to make this work is your model that you're machining always has to stay the same throughout your setups. And this is one of my biggest complaints about the whole manufacturer models, as people have asked me, is you use manufacturer model, it's a great tool, but you can't go from one manufacturer model to a second manufacturer model, making your first op, second op, or first setup, second setup arrangement, right? Ash, I hope that kind of answers your question. When does smoothing have a negative effect on finish? Usually it's when you start to get too high in your digits, TC. So if I start to really get crazy with something like this part here, if I went out and I started to really crank up my tolerance, and then I chased my smoothing with that, you're going to notice at some point, you're going to almost start to get a stop sign or a hexagonal toolpath, not clean, smooth arcs, right? Now, you could try to force something where you're like, oh, no, this is going to stay down around 4/10, but this is going to go up to 40, and now I'm going to get an error inside of Fusion. And again, is you can start to cause a problem where smoothing has changed from being nice, clean arcs to, again, you're getting very, very wild toolpath smoothing type scenarios. Jensen, I see you out there. Thanks for having all these sessions. Just subscribed. Awesome, man. I appreciate it. I just saw it this morning. We crossed 1,600 subscribers. That's wild. And just over a year. So I actually went off, started this whole thing a year ago. And with that being said, I'm still here, I guess, right? I must be doing something right. My approach to zeroing a fourth axis trunnion. So, TC, I am actually doing a video on how to set it up, but the way I actually zero my fourth axis is I put a tooling ball in if I have a probe or a coaxial indicator, and I pick up multiple points across those arcs, right? So, more of a manual approach. Now, if you're dealing with a newer state-of-the-art machine and you have a probe, usually you're still using a tooling ball, and it's going to go through and do everything for you. To give you guys a taste of what next Workflow Wednesday looks like, I will actually, let's see here. We should open back up another part. I just closed the one part that I wanted nonetheless. Let's go back to it. Got to remember where it's at. So if I was working in the world of Fusion, and this is kind of a fun thing to look at, and we're going to get rid of this Haas machine. Let's say we're going to do this on a machine that doesn't have dynamic work offsets, right? So let's just dump that Haas machine and see what I have for machines out there. AC table. Go ahead and download this model real quick. Save it somewhere where we could delete it for later. Don't do that, guys. Put that in a nice project or folder so you can come back to it. Don't do like I do, just dump it in a folder and delete it later. From that, as you're going to see normally, you're going to have everything set up here. Now, what I like to do is in my machine, somehow we ended up back with the Haas UMC. That's pretty wild. That's a new one. Let's go ahead and go back and grab this machine a second time. And we already downloaded that model, but sure, why not? We'll do it again. That is a good point from Deep Thinker. Depending on how old your machine is, your processor might not be able to keep up with the lines of code. Yeah, very common. I get asked about things like data starving the machine. I would say this is when I tell anybody, they're like, hey, we're looking at getting a new machine. What do you recommend? One, always get fourth axis pre-wire, 100%. Unless you're buying a 5-axis, then it's already there, right? But the second thing is by all means, guys, a probe and high-speed machining. I've seen hours come off cycle times because things like high-speed machining and look ahead. All right, let's try this again. There's our part. There's our file. There we go. It came through the second time. So commonly what you need to do is on your machine, if you don't have dynamic work offset, this works with 4-axis and 5-axis. What you need to define is you need to know your point of center of rotation. Now, what we do at jitcadcam, and I'm going to show you this to you guys Wednesday, is we actually put a joint origin where those center of rotations are. If your machine does not have tilted work plane, compensation, cycle 800, so forth and so on. But a quick way you can kind of get away with doing this is when you're designing your jig and fixture is usually you put your part in and you pick up your part location. Well, what I tell everybody to do is to use a joint origin. And now this is where it's very important. As you guys saw me talk about this earlier, this file is my manufacturing file. You see this lovely little Tetris block up here? And see how there's no bodies in this section? I brought my part in, did this the right way. I brought my jig in, I placed my part in my jig. Well, knowing where my stock is in reference to my center of location, that's where I could go through and I could create a joint origin. So if I was going to go off this corner of my machine and I know my part sits, and I'm going to be a little crazy with this just because it's kind of fun to see this, but this is the location of my stock from my centers of rotation, right? So when I go back to my manufacturer side of things, and it may be a little difficult for some of you guys to think about this is now a selected point. And what that selected point is going to be is where we just created that joint origin. So I'm going to have to get moved around here a little bit so I can grab it. So there's my joint origin. And then in this case, our table attachment point, I don't have a joint origin on this machine, but that table attachment point for demonstration purposes is going to be right here. And then of course our Z distance would be 0. So what we're going to see now is our part definitely sits down in the table. And this is where I tell a lot of people what really matters is how your stock sits in your jig for the most part. And then the distance from your work offset, which we would have to move our work offset also, because we would go off that same point that we used for our joint, or actually our work offset would be that joint origin. I apologize. This is why I'm making a video about it, on Wednesday, is we would go ahead and define that as a selected location also, because the idea is that is going to be our reference at our machine controller, right? So all of our machine moves, travels, tilts, and everything. I see somebody in Discord. Give me a quick second here. Hey, we got more people joining Discord. Let's go. So again, is using that joint origin to define where our center of location is, center of rotation is. I always tell people when you find your center of rotation, you make that G59 at your controller, and then usually you never use G59, because if you're going to use 54 to 58, that's 4 offsets. Now, if I need more than 4 offsets, I usually go to my P values, right? 154 P1 through 1000, right? But once you put that in and you know where that location is, until you take your rotary out, put your rotary back, it makes no difference because it's always going to be that same location. So in Fusion's world, the quick runaround is we've used the origin to define where our center is from our stock. We've set our work offset to that joint origin. And then for Machine Sim, we would have placed that joint origin on the joint origin that jitcadcam over here built in your Machine Sim. And that will allow you to automatically place everything, get it lined up, get it where it needs to be, so that it can be a one-to-one replica to what you plan to machine. So, TC, I hope that answers your question briefly between now and next Wednesday, because I can't tell you how many times I get questions from like Haas guys with TRTs and the older Fadal machines. I've seen a lot of Fadals with 5-axis rotaries on them, and it's the same thing, right? These machines are old. They don't have the tilted work plane and all the fanciness. How do I program from center of rotation? Cool. Any other questions than that? I see more and more people jumping in here. Been streaming for a whopping 49 minutes. Should I hit you guys with the sales pitch real quick? I can hit you guys with a sales pitch, right? As always, all week long, we are creating more and more content. This week, this is our 3rd live session this week. So with this session, as you guys can see, is we do Wednesday, Workflow Wednesday every week, free support Friday every week until you guys stop showing up. And then Mill Turn Thursday. So we need subjects and questions that you guys have about Mill Turn Thursday so that we can make more and more Mill Turn content. Somebody asked for it last week, and well, we went ahead and came through for you guys. Also, if you want to support this channel in any way, there's always the like, the subscribe, comments, sharing our content with other people. But as you can see over here on what is my left, it is your left, right? Yep. That being said, you guys can buy me a beer. So there's a link down below to buy a beer, given that it is Veterans Weekend. And I'm going to go ahead and pop this up for all my guys out there. Yours truly is a Marine nonetheless. So I am a retired Marine, I guess, at this point. So that being said, is my celebration is going to start Sunday, and I'm probably going to go way too hard. Thankfully, us over here at jitcadcam don't get to take Monday off. So anybody putting in support tickets on Monday, I do have to say it might take a little bit to get a response. Don't do it before noon. But that also being said, is it is the Marine Corps' birthday Sunday. For all my guys out there, fellow Marines, you know exactly what kind of shenanigans going to happen. So you buy me more beers, I just have to drink them, I guess. Awesome. I appreciate, yeah, the beard. I've gotten the beard question a lot this week. The beard had to go away briefly. Don't worry, it'll probably be back by Workflow Wednesday, as you guys can tell. So on the DWO TCP feature, there isn't really a way to make spherical versus flat. Now, there is several ways to create a forced position to clear things as well. Again, assuming DWO TCP, you're talking about your host machine, you could actually set a location in your machine as well to generate those locations or safe positions for multi-access. How do you set up G154 in the post? So, Brett, oh, I see you out there. All right. So G154, if you're using G154 is HOS, if I'm correct. So if you're actually using machine configuration, and I'm going to swap this back out to a HOS machine, maybe. Usually it yells at me. Automatically based on how the post is wrote, and we can add this to any post, guys, is you have standard versus extended. So your extended post locations, G154P1, and if I was to change this to, to 15, it's automatically showing you right here that you're going to G154P15. So Brett, I know you quite well. We've emailed back and forth. The G154 is technically already there if using a machine definition, right? Now, if you're not using a machine definition, that's more than okay, guys. What's going to happen is your post actually has it in there by default, but you need to know the math on it, right? So in this case, I need to know that, 1 through 5 is 59, and then 6 would be P1, P2, P3, so forth and so on. So again, is work offset 1 and 0 is usually your default work offset, or 54, or you fit all guys, E1. So I would need to start with 6 and go up from 6. And from there, when I post this out, my post processor will actually swap automatically from 54 to 156. So again, we'll just, in this case, our HOS next gen post, get this posted out. And then as you'll see here, we have our G59 because yours truly put 6 and not 7, because if you've ever framed a wall, you know that you have to add one more for the starting location, right? So let's go back to our setup and swap that out to 7. And now hopefully this time we have the luxury of me not being a liar, right? So here we go. And we're going to go ahead and repost that code. And there we go. So Brett, in your case, it's already in your post processor. So just based on the number that you put in there, this is why machine definition is so great. And with machine definition, having your post support that machine definition makes life a dream again, guys. Oh, can't. Oh my God. Look at, there it is. There's the problem. There's the problem, guys. We're gonna go back, and I'm gonna go back through all that because why not, right? Thanks, Matt. I appreciate it. Just caught wind that I wasn't sharing my screen. So from the top, in your setup, WCS offset 7. We go ahead and post that out. Again, now you're going to see, not just me, there's your P1 automatically, right? And again, is based on your setup of your post and using machine definition, as we just talked about, is it will auto-populate that information over here in your post-processing side. So you could swap from standard to extended, and then again, you can change it to whatever you need. Again, I highly recommend you guys start to use machine definition. And there's a lot of reasons why you want to use machine definition. And some of those reasons are, if you're like me, that's starting to get multiple tabs open and I'm doing a lot of different things. Now that my post is tied to my setup, if I have to go run something on a machine and hit post process here, it's automatically pointing me in the right direction versus the old days where you would have to switch. Oh no, we're going to run this on the Akuma. We're going to go put it on the Fadal. You got to remember a whole extra step. So again, we could go in using that same post in this case. Now we're going to get our P15 value. Navy Seabee, awesome. And Air Force, that's awesome. I always love meeting fellow veterans. Obviously, we're all going to Denny's on Monday to get free Denny's, right? Denny's is free. What else? Buffalo Wild Wings. I think Buffalo Wild Wings is usually a free one. Casting part reference. Fusion CAM samples, 2D adaptive mirror. All right, let's do it. CAM samples. Tutorials. 2D adaptive milling tutorial. Come on. There we go. And all right, let's see what we got. So they just have something simple in here, but you're curious about a casting of something like this part. So if I was to do a casting, you guys are going to see me shortcut this a little bit here real quick. We're going to go ahead and file, save this over, just because it's one of the sample parts so that we can manipulate it. The idea is in Fusion, it's always thinking of from stock to part, right? Unless you're 3D printing, then it's thinking nothing into something. But I need to turn things into components to make them work for me. Now, I am going to go in and I am going to create a component, and then that is going to be my part, right? So this is the part that I want to end up with. If I was to make a casting, or if I had a model of a casting, it would work to my advantage. But we're going to go ahead and copy, and I am going to paste new. And the reason for a paste new is because I need a version of this to manipulate that isn't connected, right? So usually your castings are oversized. There's material that needs to only be removed in certain areas. This is where by prepping the models correctly, we're going to have a lot easier time on the machining side. So what we're going to do, and this is, somebody pointed this out when I was talking about model on Wednesday, is so that your parts don't get moved around. As you can see, I can click and drag one, but I can't click and drag the other. Well, the original part is anchored. Now, my second part is not anchored. So it's up to you which way you go about this. We made a direct copy. I could actually go in and ground this. So now that neither part can be clicked and dragged, right? Another way to go about this is we could actually do a rigid group. Now, rigid group works nice to just be able to grab multiple things, stick them together. Same outcome. They're not moving around. You don't want your parts to move, right? I've seen this. A part moves 5 thou, and then your whole part's out of tolerance. Becomes wild. So what we're going to do is I'm going to isolate this part, and then I'm going to activate it. What that allows me to do is generate my timeline against this part. Hopefully your engineers have provided you with the casting and the machined part. But on a simple part like this, using press pull goes a long way, right? So let's say, for example, inside this pocket, there's going to be 20 thou worth of material everywhere. So what you see me doing is I'm going through and I'm picking all these faces. Now I got to get in here close enough to get this face. Used to have a space mouse, but the thing died on me. And I'm going to give 20 thou material there. I'm actually going to add 20 to the floor. And let's just say, for example, we're going to add 20 up top too, right? So as you can see, is with nothing more than the press pull tool, I can actually go through, in most cases, add material to something. So there is the option to also possibly scale something a little bit if you had to. But what we're really looking for is a model that we want to machine versus the casting, right? So for the sake of this part, I'm actually going to turn this opacity down to 10. And then we're going to go back and turn everything back on. And then let's unisolate our part. So as you guys can now see with the ghosting image in the background, I have the part, one versus the other, right? And now I could take this a lot further than this, guys. If I wanted to, I could come in, remove the chamfer. even remove the drilled holes. And I'm just using the delete key. I'm not doing anything fancy because you would obviously add these holes after the casting process. But the idea is still the same, is when I go over to manufacture now and I go to do my setup, what I need to do is I need to define my part, right? Again, this is where our components come through. They're your best of times. So there's my part. My stock now is from solid, and my stock is going to be that part that we've manipulated or created our casting off of, right? So the casting is now my stock. We also need to put our z-axis up because for some reason Autodesk, when they put this in the library, didn't think that, we should probably put it in the world coordinates in the right direction. But as you can see, my z-axis is now up. So if I was to go in and machine this part, and I'm going to go ahead and hit F8. Let's make sure our stock is turned on. Okay, cool. So going in and doing something like adaptive clearing, for example, it's automatically referencing where our stock is versus our part. Now, in this case, you guys may criticize me a little bit because yours truly only put 20 thou material everywhere. So I need to actually change my radial and axial stock. I also need to go ahead and scratch my head because this needs to be changed over in what we call bald eagle units. There we go. And now let's go back to that tool. So initially, I just got an error. And the reason why I got that error, if I can back it up here real quick, is because there's nowhere for that tool to actually machine, right? So it says Toolpath is empty. Well, can anybody in chat go ahead and guess real quick why it says Toolpath is empty? Deep thinker, I'll jump back to that here in a second. But the reason why I have an empty toolpath is because my stock to leave is basically identical to what else I had going on. And for those of you asking, I went ahead and pushed Control Z in the background to undo everything. That's why my inch unit has changed. So if my stock to leave was to actually be 10, what you're going to see now is because of the recognition between the two, which it's given me a little bit of a problem here, it'll go out and pick up the stock versus the model, right? And that's what we're going after at the end of the day. So let's go ahead and do that one more time. Go ahead and just kick off stock to leave. We need to also, let's go ahead and turn off, there we go, remaining stock. And our ignore less than is killing us as well. So we could actually turn that back to 10, and then I'm going to turn stock to leave back on. And as you're going to see, we should get a toolpath now, knock on wood. And that's what's happening, right? So now you're seeing where that stock is versus isn't. So going back to Deep Thinker's question, we're going to go back in and to go to design, and you're going to see me massacre this part more than ever. So as he's saying is that part as a whole has 0 pockets in it. I luck out, these are square pockets. You guys could go in, highlight the faces, and in Fusion's world, in most cases, it'll actually auto patch itself. So if I went in and say delete face, it would get rid of that pocket altogether. Now I'm getting an error that it's not going to do that on this one because, well, we got to go ahead and turn off the original part where I was selecting all those edges. Or I am backwards. Let's see what's going on here. I think I'm backwards to the world today. We have somehow added the hole back to the corner. So yours truly is messing this one up. All right, that's okay. So let's go ahead and go back to the top and start fresh, right? So we have our original part. We have our modified part. Yeah, somehow lost our, oh, duh. I just deleted our timeline, didn't I? That's me. That's me. See, you guys out there, looking at all of you, you put in tickets to me, you say the software's junk and it's broke and all these problems. Yours truly has the same problems. I just have to think faster. So let's do this all over again. Let's activate, isolate, and like he said, we can go through and manipulate this part. So we could remove screw holes in the corners. What should work this time now is picking all these walls. If I wanted to remove a pocket, again, I'm doing this by holding my control key, hitting delete. Now it works. Big surprise, right? This is you guys. You guys put this in. You put a ticket in, you're like, Toolpath doesn't work. I go in and I hit OK, and it works every time. But I could also, on this part, we could actually do an extrude because these are square pockets. Pockets are gone. This same method that we're doing for a casting, if you guys are dealing with like flame cut parts or water jet parts, the idea would still also be the same. Commonly, most of you that have ever worked with the EDM even, you add some extra material here for the EDM to come through. I'm just manipulating said body. That's all I'm doing at the end of the day. Again, let's just leave this pocket alone, but if we go through and we do our press pull again, I can go around, grab all the surfaces that I want to make larger. In this case, we're actually going to make basically this entire part 20 thou larger. And we're also going to find out whether or not Fusion will handle this very well. So actually not 20, we're going to go 0.125 because that was the request. And now to compare the two, you could see this entire part is now 125 thou bigger. Again, we could change that opacity just to make it so that a little easier to see. And in order to see everything else, we need to activate everything else. So it looks like I failed to do one of the sides. So we can go ahead and go back, pick off the original part. There's that face. Now it's 125 everywhere. And again, we have that all set up inside of Fusion. So there's our part as asked, based on a casting with or without pockets, with 125 worth of excess material. So if I go back into manufacturing, again, we go ahead and regenerate our toolpath. What's going to happen is Fusion is looking for anywhere it can machine versus where the actual physical finished model is. Again, same concept, whether it was large scale, small scale, scaling up a part, scaling down, used to do vacuum form fixtures. I mean, we had to put shrink on parts because when they cool, they would get smaller, things like that. Deep thinker, does that kind of answer your question? Roadhouse and Applebee's. Applebee's has stepped their game up. I tell you what, Applebee's is quite the place to go. I live in the middle of nowhere, so I will not be partaking in any restaurant shenanigans. You like using Simplify to remove unwanted features? That's one way to go about it. Yeah, 100%. Simplify or the way I did it with press pull? Go ahead and give you a second to answer there. In the meantime, anybody else has any other questions, feel free to jump in and ask. Obviously, we're here for you guys. We've been at this now an hour and 7 minutes, and we plan to go about another hour. So if you guys have questions, we always love to get questions. We love to see situations that you all are experiencing or things that you would want help with or common issues you may have. If not, I got another part I can pull up. Cool. Let's go ahead and see what other part I have while you guys put some more questions in chat. So we're going to get out of the old cam samples. Let's roll back to our YouTube content. And this part is actually coming to us, nonetheless, from, where was he in chat? Gert. Gert was messaging me earlier about this. So one of the issues he was facing is, I'm going to go ahead and see if I can undo everything he had here. Give me 1 sec. But basically what he wanted to do, I'm going to create a new toolpath to show this, is on a part like this is his scallop toolpath. He was very curious about, how do we go about using the new avoid touch machining? I would like to really clean up this part in any way possible. Now, we did get him down to quite the nice part, but I think a lot of people still are overthinking. They think that the avoid touch machining is like, that's what they're supposed to always use. And I don't see it that way, because if that was the case in a toolpath, as we've seen an Autodesk recently do, they put everything in an order of operations, right? So the idea is now you actually select multi-axis. So if you've ever called me on my phone for support, when I try to walk you through things, hey, I need something in the heights tab is no longer the 3rd tab, right? It's now the 4th tab. But the idea is that when you turn on certain things here, it actually causes other things to happen later in your toolpath. If you're like me, you rush through, you do all this stuff here, and then you realize, oh no, I need to do tool orientation. It's the same concept with the geometry tab. It's the same concept with the passes tab. If we think working top to bottom and going through and actually setting everything up, in this case, we could go and I always tell people bare minimum at first, right? We always just hit OK, right? So what I'm going to do is I'm going to hit OK on this part and realize that we're not going to do this with that lovely pointed tool. We're going to swap back to tool 2, which is a ball. But the idea is we need to get a path on the part. It's much easier to troubleshoot our path and change our part once we get a path on our part, right? So as you guys can see, is we're not going all the way down our part right now. So we could go back and we can adjust from that. And the reason we're not going down our part all the way is we have our tool center with our silhouette. And if we turn on something like contact point boundary here, what's going to happen now is it's now going to take that tool and wrap it all the way down around the outside. Now, as you could see, is we're getting that waterfall effect, right? And a lot of things can cause this waterfall effect. I see it quite common when you use silhouette, right? Because it's thinking the lowest edges of that silhouette. And I think this is where people miss some of this stuff. Is if I was to go back to that same toolpath, and it's going to be a little silly, but if I do a selected boundary and I pick the lower edge all the way around this part, right? And I hit my OK, and we leave everything the exact same way, what you're going to notice is for the most part, it's no longer going all the way down to the bottom all the way around, right? It's still chasing that lower curve that we have defined. So this is where I tell people that you want to kind of go through each one of these steps and do the absolute most that you can here before going on to the next step. So now this is where I could add in avoid touch machining if I would want, right? I've gotten this path pretty straightforward, narrowed down to where I want it. This is where we could go in and now add our avoid surfaces, right? So if I didn't want to touch these walls at all, is what I'm going to do is I'm going to go now in and I'm going to create that group of surfaces. And what I can do with that at first start is we're going to go ahead and leave them at 0. And just by turning that on, we're going to see if we get any different results, right? So we actually haven't got any different results. And this is, again, something that I see a lot of people not really think about or look at is the avoid touch surface setting is currently set to 0, right? So if it is 0, it still thinks that there's a surface there and I could get to 0 on that surface. So what I would need to do is I would need to give it some type of dimension to stay away from that surface. Now, there is a radial versus axial from the tool direction, so you have to remember that. But by adding in 10.1 millimeters, I guess, according to the way this is set up, notice how much I can clean up this toolpath fully all the way around that part. So by being able to set that up and put that in there, let's get the toolpath points turned off. Again, I've been able to adjust and manipulate what path I got, right? So I got a path, then I narrow down where I want that path using avoid touch surfaces. Now, again, another thing I see from a lot of people is we can actually create multiple groups of surfaces with different settings. So if I wanted to, I could go in and add additional surfaces, which is something he was looking at doing. And what I would like to do is stay away now, again, from all of this stuff down here. So what I'm going to do is I'm going to go through and pick each one of these. And then again is now I could leave an axial or a radial setting here. So in this case, this may be more axial because we're vertical and it's vertical off that face, right? So it's coming perpendicular off that face. But this time, you notice how it didn't change. Well, it didn't change for a couple of reasons. One of those is, again, I'm moving too quick. But we need it to be an avoid surface, not a touch surface. And again, we could add in our 0.1 over here this time. But as you can see, is you could start to set up multiple groups. Again, a reason why I went vertical here is because I don't want it to go horizontal and stay away further into my next surface, right? So I have to be aware of that and the way that works. But again, we could go in one more time. This is a critical bore feature. We're going to cut this with a flat end mill later. We go back to avoid touch surfaces. I add another group. I can pick that couple of inside surfaces if I'd like. Again, maybe we want to stay away from that 1 millimeter because I'm going to go back later and machine that with a flat end mill. This is the luxury that you got. So it looks like nothing has changed, but we're now staying 1 millimeter off that surface altogether. So again, this is something I've started to see with the new Avoid Touch surface is I like to compare it more to like the design workspace. Create your toolpath, then modify your toolpath, right? So the same concept, right? So you go in, you go through your process, you've created the location of your toolpath. Now we can modify by changing slope. You know, do we want to go through and add additional models to avoid features, so forth and so on something like this? I will also say for a lot of you out there is using rest machining and when you do things can make a massive difference inside of the software as well. So by turning on rest machining now, again, we have the ability to ignore certain areas of stock. So given he has actually already roughed this part out prior to, let's go back one more to another roughing strategy. Oh, he drilled it out. That's what's going on there. So he drilled out that actual bore, and based on that drill size, would determine what we get from our actual scallop toolpath again. So if we were to change this down to 0.1, we should get a little better result. But as you're seeing, by having a ignore stock less than 0.1, as you're seeing here, and then leaving 0.1 on that group wall, I can do both of those things, right? Kind of a nice way to look at it and a different way to group stuff together to really streamline this toolpath and clean this toolpath up a ton. I see a few more questions coming in. Brett's got another question. Yeah, so you have a tight tolerance feature on a part. How can you use the probe to adjust your tool wear? Well, I am actually going to grab a drink of water and I'm going to be right back and we will visit exactly that. So give me about 5 minutes, guys, and I will be right back and we can look at how to use the probe to adjust tool wear. All right, we're back. All right, Brett, you ready for this? Let's go ahead and do this. So this is actually a pretty good part that we have inside of Fusion 360. So I always ask people, when you're dealing with wanting to do what I would call an in-process inspection or a probe geometry as Fusion has it, is how critical is that tolerance? Do we want to pre-cut something and then measure, then post-cut it? Or are we running, 1,000 parts where we can measure every one and then just cut it after and be okay? And we're going to set up both scenarios here. So what I'm going to do on this part in particular is we're going to go in and we're going to do our 2D contour. And we're going to grab our tool. In the lovely world of these tools, we have millimeter tooling, which won't make a big difference. But as you're going to see me do is we're going to go ahead and pick our geometry for our bore. And what is common to happen here is we're going to leave stock on those walls. And in this case, we're going to leave 0.1 and 0. I cringe with these millimeter units. I apologize to you guys for having to bear through this. But as you can see, we've now gone in and we've cut and we've left stock on the walls, right? So this is where I would go in and I would do an inspection. And we're going to hit a probe geometry. And I'm going to go out and select my probe. In this case, I believe I have one somewhere in my cloud. Usually I have one in my cloud. There it is. And we're going to go in and we're going to measure our geometry, right? So as you're going to see is we pick our bore. From our bore, we could set a position and size. And what we're going to do in the Actions tab is update toolware. Now we need to update an operations toolware for what we're doing. So if I go out and I pick that 2D contour and hit OK, what's going to actually happen is we're going to get an error. But before I lose my mind, we're going to go ahead and switch this from millimeters over to inch. There we go. And the reason why we're getting that error is the approach distance. So let's go ahead and adjust the approach distance. And that approach distance needs to be less because we're over traveling our probe in there. And now we actually have a position versus a size. So if I wanted to hold plus or minus 1, I could set that plus or minus 1. Again, updating our toolware for our stock. And this is one thing that I loved in Fusion. Like when we first saw this get released, it was crazy to me. Is even though we have stock to leave turned on, it's automatically picking up that radial stock to leave. And with that radial stock to leave, it's accounting for that in our probing cycle, right? So this is huge to me at the end of the day. I absolutely love this. Now, a couple other things is you never actually want to make a full correction. So what we're going to do is we're going to make a minimum setting of adjustment threshold. So once this bore gets out by 5/10, then we make a correction. Now, we don't want to go from 5/10 back to 0, right? I would actually tell most people, you only want to make about an 80% correction. So once we get to 5/10, we're not going to go all the way back to 0. We're going to go back to about 1/10, right? So what is going to happen is sometimes you can just get a weird spot in the material. And if you overcompensate, you shoot back the other way or you overshoot your actual correction, right? So instead of trying to get it dead on, we could actually walk it back to that location and still keep us all within tolerance, right? When I first started out machining, everybody wants to be perfect, right? It takes years for you to learn. Once you're in tolerance, the part still makes the same money. Stop messing with it, right? So as you can see, we went ahead and did our probing. I'm going to go ahead and regenerate our toolpath here real quick. Now I am getting a warning. And this, again, this is why I love Fusion. I came from Mastercam, guys. This is what makes me absolutely happy. We failed to turn on toolware to update, right? This is a big thing. You obviously want to cut that bore, whether it be pre-cut or post-cut, with wear turned on. Because what are we going to adjust wear if there's not wear on the path? We would just be chasing our tails, right? So we go back to our toolpath. We go to our passes tab. We click on our wear. And we go ahead and hit OK. Again, updating our probing after the fact. And now you can see we're error-free between the two. Now, we pre-cut that undersized. The probe took into account, and let's clean up these numbers here real quick. So we have a radial stock to leave of, let's just leave 5 thou, right? So we went in, we left 5 on the walls. Our probe is now picking up automatically based on that information. So now you can see our radial stock to leave is, in addition, 5 material. And now we can post cut that. So usually what I do is I duplicate that first probing cycle, drag it down below. Again, we're going to go into that cycle, turn off our stock to leave. And just like that, we've now pre-cut with 5 per wall, 10 on the hole, probed it, accounted for the stock to leave. And then the second time now we're cutting it with that tool, we should be spot on almost, because again, 80% correction, plus we're allowing it a little wiggle room in our actual cycles. Now, if you wanted to, you don't need to go through this crazy of an elaborate situation. We could have not pre-cut it. So I'm going to go ahead and delete that pre-cut. And Fusion's going to take a minute to think about that. We're going to put that probing after our initial contour. And then again, I'm going to update my geometry based on our tool wear here. So again, we need to probe it after cutting. And as you're going to see, it's going to take a minute to load because I am streaming everything from the same computer. But as you see, we're cutting that bore and then we're probing that bore to measure it. So on our next part, we will actually see that correction. But you can take this a little bit further, Brett, where we could actually cause the machine to shut down if it's the wrong size. So one neat thing is, let's say you break an end mill, we could actually have the machine stop with a message, and that message would be, hey, this tool has, this hole is way out of tolerance, right? So again, this is why we set, in my opinion, your threshold. Usually I go with half of whatever my actual size tolerance is, but that allows the machine to auto detect an error, alert an operator to get that swapped out. Cool. What other questions do we have outside of that? So Deep Thinker is asking, so in order to do probe geometry, yes, you do need the machining extension. So in the base license of Fusion, you get probe WCS, but to have advanced probing features like that probe geometry, inspect surface, part alignment, which is a lifesaver, all of that stuff, you do require having the actual, it's now the manufacturing extension because you get nesting all rolled in there too. Well, 100% Deep Thinker, you would have to actually have the manufacturing extension. Cool. With that, do we have other questions? Anything else? Oh, another question just came in. Keyway broaching on Discord the other day. How would one lock the spindle for sharp edge cuts using a Haas A axis? Lock the spindle. So you're using a Haas A axis and you want to do broaching. You're not using a right angle head for broaching, right? Because to me, I'm thinking, is your A axis vertical or is it? I think I know what you're doing, if I remember correctly. Let me pull up Discord here real quick. To say the least, are you trying to use your A axis as what would be referred to as C axis vertically so that you can cut multiple keyway broaches? I apologize. I'm on my other monitor here real quick, so I don't see chat if you've messaged anything here. Trying to find your original Discord message. Oh, yeah, I remember what you were talking about. Okay, yep. So you're going to manipulate the G code, or we would have to modify your post processor. Yeah, so when you do basically keyway broaching, I'm going to take any toolpath here. Normally, the trace toolpath, as per Matt Van Loo out there, works quite well. But upon posting whatever it is that you plan to do, and again, it's going to be based on what your machine can do. What you're going to do is you're going to actually remove this line of code, which is your spindle being turned on. Now, some machines have an M code to lock the spindle or an M code to orientate and lock. Now, keep in mind, you do need to know that orientation call out if it's not perfectly squared up to the machine. but you could simply go in and delete this, and then from this type in, maybe it's what's a random one? M160 or 144, and then maybe there's a p-value 60 or 50, which is the angle of tilt. So you could actually turn the actual head and orientate your spindle based on a certain degree as well. But then you would run your cycle normal as can be. It's still going to work the same because you're doing X, Y. In your case, it would be either XZ or YZ based on what you're doing. Now, if you're going to do this and kind of cut a spline, a female spline versus a keyway, you could go in and then with patterning, use that A axis to rotate and cut it in different areas. Again, you can lock the spindle. Some machines get very, very fancy out there where you can actually orientate the spindle to different locations. And I've modified a post for somebody to do that, where instead of spinning like an A or a C axis, we actually orientate that machine. But we would actually do quite a bit of post work to get that to work. But yeah, to say the least, all you would need to do at the end of the day is remove that spindle on command and then put in whatever your spindle lock code call out was. And then from that, you can go. Any other questions outside of that? Quite a few questions coming through. Brett, hopefully you caught what we were talking about when I showed you there. Is that going to work for you? M19R0. See, look at that. You guys are helping each other. That's why we built this platform and we're doing this, right? So 100%. So when he goes out and he posts that code, at some point you guys end up in my case where if you've ever been to a shop that has like 15 different controllers, you can't remember what it is, but it would just be, just like he said, M19R0, and that would be spindle orientation. And again, is depending on your machine, you can sometimes on machines say, I want to rotate R15 to clock that to 15 degrees from R0, right? So if your R0 is your tool change 0, then you want to go 15 degrees from that. But that would be the key thing to look out for on most machines, is you need that broaching tool to be either in, the 12 o'clock, 3, 6, or 9 position, right? So we can use that R to compensate it. Hopefully that answers your question. Let me know in chat. In the meantime, anybody else have any other questions? Anybody else? I've seen quite a few orders for beer come through. It's going to be a pretty rough Monday for Veterans Day after the Marine Corps' birthday. Go ahead and leave this open. Anybody else has any questions, guys, feel free to reach out. Trying to think what else I've had to overcome this week. It's been a pretty wild week as I've been dealing with a ton of different tickets and Pearson work holding and vacuum fixtures and all kinds of fun stuff. For anybody that's just recently joined or jumped in here, feel free to ask any questions you might have. We're here for you guys. Any type of Fusion Toolpath questions or design questions you may have. We covered design a little bit earlier with that exhaust manifold. Trying to think what other crazy parts I've had all week or crazy scenarios that I've heard. Should we do a complaint to Autodesk about certain things? Go ahead and clean up our workspace while we wait on more questions. You guys all slowed down. It must be a busy Friday. Is there a way to link stock to leave with tolerance? I believe so. I'm trying to think what would be the best way or the use case. You could definitely. Are you wanting an equation that links the two? Because if you go in and you click these three dots, you have the ability to edit an expression. And in that expression, you could actually search whatever it may be that you need. So it looks like Matt's putting it in there. Just put plus tolerance. And you could 100% adjust that. Again, is depending on what you're looking to do. Actually, he wants to do stock to leave, right? You want to do your tolerance off stock to leave. So we can go up here and we can click these three little points. We can go to edit expression. And then depending on which way you want it to go, you could search in the parameter. So there is several different things: rest material stock to leave, sim stock to leave, use stock to leave, vertical stock to leave. So it just is a matter of which one you're looking for, or going the opposite way, which would be when turning on stock to leave, I could go in and I could edit an expression. And then just like Matt was saying, you could type in tolerance and then figure out what your chaining tolerance is and so forth and so on. I'd be curious to know why you'd want to link your tolerance with stock to leave. Or are you thinking like, if I put 10 thou radial stock to leave, adjust tolerance to 5 thou, right? Cool. Any other questions, guys, while we get some more info in chat? For those of you new to this channel, my name is Phil Brown over here at jitcadcam. I go by Fusion Phil for the most part. I've been doing this for a ton of time, as you can imagine. I think there's still videos on Autodesk channels from my day back then. But outside of that, we are bringing you guys free support every Friday based on any of the questions you may face throughout the week. I see a lot of you guys reoccurring all the time. We're here for you to help in any way we can. So whatever those questions might be, please put them in chat. Please send them to us on Discord. You can even put in a ticket with a support email down below. We're happy to answer those questions live, or if need be, we can always answer them offline based on privacy reasons. Maybe this week we just got to call it short. Or should I just sit here for the next 20 minutes and twiddle my thumbs? I know a lot of you guys joined after I started. Did you guys see? I finally realized after a year and a half that I was backwards the whole time in my videos, and now you can read my logo. Almost had to start wearing my shirts backwards. Not backwards, inside out. What am I thinking? Must be changing parts. All 12 of you guys in here. I think I saw a record high at one point for 20 people. Can I probe something other than WCS to update WCS? Yes, 100%. So kind of a neat thing inside of Fusion is if my WCS on a part like this was over here in this right-hand corner, and I was going to load another one of these to run, but I'm not going to probe this corner, when using probe WCS, anywhere that you put that feature to be probed, in this case, we're going to go ahead and let's say we're going to go off this set base here, is when I'm probing this, is Fusion is going to automatically calculate the compensation in X and Y. So if I was to post this out now, and we'll just stick with the Haas post, what you're going to see is we're going to go over to that location and we're going to probe. And then from that location is it's going to automatically compensate and adjust our part, where our part is. So again, kind of nice to be able to quickly go in, set whatever that information is, and to be able to jump back and forth. But yeah, you don't have to probe your WCS. It doesn't have to be at 00 by any means. Ah, okay, Deep Thinker. That makes much more. So terrified to try it. I mean, hey, now you know. I mean, as long as your post supports it by any means, usually what's going to happen is you would error out your machine in some way, shape, or form. I mean, as funny as it is, I had somebody earlier asking me about rigid tapping with a FANUC post. And in his case, he didn't even have rigid tapping on his machine, which was his problem. But it was quite a while conversation that he's had the machine for years. He needs to do, almost a peck tapping cycle. And we got him all squared away to find out that the machine can't even do it. Poor guy. But yeah, so on your machine, Deep Thinker, I actually covered this. So we can actually put smoothing at the toolpath level and then being able to set everything up that way. But you can also edit your post, right? So there's a lot of different ways to do smoothing. Now, the way that we showed this in our video is depending on your actual post processor, which yours sounds like it has it, which is great. We're going to actually go out and we're going to grab a post that I can brutally break today. And what do we want? Let's go with FANUC. That's what you're talking about is the FANUC post. Let's go ahead and copy over our FANUC post into our testing area. And what's going to happen here is I'm going to hit edit on this. So by default in the post processor, wouldn't be a normal Friday if we didn't talk post, right? There is an area for smoothing, right? And by default, you have all the different levels, and you can set this at the top level of the post. So for those of you wondering, is you can actually go down here and you can say use smoothing. And then what you're going to do is just like your setup in Fusion, it's going to be that smoothing setting for everything. Now this, for a beginner user, is all right. But if you're out there running a part like this, I don't want to go and use a high level of smoothing for roughing, right? I want to use a high level of smoothing for finishing. And then on my roughing, I want it to be as loose as can be so we can run fast, right? So in our post, you actually have the ability to set what's called automatic. Now, what automatic is going to be used for is it's going to automatically calculate your smoothing. If I could find it here quickly. And we might have to go with the word automatic. You guys are getting the business here. You see me Control F this whole thing. So what's happening down here in this specific area, as you're seeing, is you have different criteria. So you can either use the stock or the tolerance to determine what automatic mode is being populated, right? So this is kind of a neat thing when you think about it, is you have your different settings. So again, 1 for roughing, 2 for semi, yada, yada, yada. How that is being calculated is based on your 2 precision unit here. So as you can see, it is in millimeters, guys, and it will be in millimeters in your post, but you can convert it to inch. So again, as if we change stock to tolerance, the tolerance of what he is talking about now controls when this smoothing is populated, right? So based on automatic and using tolerance versus the stock to leave, and so you can all see this as we're going to go into our toolpath here, is he is now able to adjust it here at tolerance versus adjusting it down here at stock to leave. And again, based on millimeters, guys, so if I was to go in and say, 0.5 millimeters, it would cause blank stock or smoothing to happen, right? Or 0.05 millimeters would cause, less than, technically is the way it's calculated. Well, when you don't have stock to leave, it always goes to the tightest. But if he wanted to, he can now control it with tolerance here. But I don't recommend either one of these, right? So with that being said, what I highly recommend, Deep Thinker, is what you do is you change your post processor. And what we're going to do is we're going to go back to that FANUC post. And all you have to do is, 1, go back to the top of the post, of course. But if you go down here, is you have all of this stuff. And what you see for scope is if you turn this to operation and hit save, what's going to happen is you are going to need a machine definition for this to work. And I did this on a video, I think 2 weeks ago on my Workflow Wednesday, is if we go in and we pick our machine, and you don't have to have a full machine build as everybody thinks, is I'm going to grab this Autodesk generic 3-axis. And again, this doesn't have a model tied to it. It's not a full machine sim, but I need to tie it to that post processor, right? So we're going to go into that FANUC in testing. And what you're going to see happen by picking a machine, again, this is another advantage that we have by putting our machine at work in the setup. All my smoothing stuff has come through automatically, right? So what this now allows you to do is to say, screw the tolerance and the stock to leave. Not actually, because you still need it for clean toolpaths. But If I go to my toolpath, I can now go over to post properties and set it right here in real time, right? So each toolpath now has that individual control, right? So again, in a lot of things in Fusion, you have multiple options, almost like a global setting versus a local setting, right? So globally, you could just put on automatic, then control it with all the little ins and outs and remember that. Now, me personally, we could do a local setting 10 times easier, right? Again, most of my stuff could be set to on or off, or if you have just like always run 3, right? We could set 3 as the default, and then you can go in and fine tweak it from there. So this is, again, super pro tip. We did a video on this, I think 2 weeks ago, based on that information. So I see another question coming from Matt. And how about if I want to probe a feature at A90 and update my WCS? Will it store those values? This is a very tricky question because a lot of machines can't actually do that. And I say the machine. So in Fusion, you can probe at angles. However, will your machine be able to do that math is always going to be the wild side of things. So if you're running something like a Siemens with Cycle 800, I believe those machines for the most part can do it. Now, what I recommend to most people is if you're going to do an A-axis tilt and probe, now the way to get around it in all cases is to actually compensate your work offset with the A-axis tilt inside of your controller. So I think somebody was asking before is, do I have to probe where my work location is? No. And the same thing goes as when you do a probe WCS, you actually have the ability to override your actual probing system. Now, again, I tell people this all the time. I always get this mixed up, right? So if I was to go in and say I wanted to use 55, this is going to update 54 from 55. So the way this works really, really well is my XYZ location in my controller for 54 could stay the same, but my 55 would then have my A90 compensation. So it calls WCS 55, goes in and probes, then updates 54. So I see Deep Thinker coming in. I would need it to be automatic and actually calculated from stock to leave. No brainer, click the top rates. Yeah, I mean, 100%. So you could still leave automatic in there. I mean, usually we take automatic out because that's what most people want is they want that fine-tune control and then default to like level 4 and then pick it from there. But you could, by all means, you do have that ability in your post processor to be able to set even that default value. I believe you could actually do it even inside of here where you could go automatic and then save as user default. And then with that, the next time you go to pick a toolpath, in this case, it didn't update the automatic user because that's not a actual user, but you could change it in your post processor. Again, this is the fun of Fusion and you guys knowing people like yours truly over here that could come down here and instead of it being level -1, which is off, we would change it to level 99999, right? So again, is a little copy and paste here. We hit save. Now, if we go back to Fusion again, let's pick a new toolpath. What we should see is automatic is now your default Deep Thinker. So again, super handy thing as you're seeing is that ability to change it at the post allows you to update it right here as automatic. Another kind of neat thing is now that you're using a machine definition, you go ahead and pull this edit up. There's even the ability, if you wanted to, is to place it right here inside of the post. Not the post, but the machine definition, right? So you can even put the option here if you wanted to start controlling your stuff. And this is something that I've started to recommend is by using machine definition, we can display all your post properties right here. And with those post properties, you no longer have to deal with them when you post out, right? So it's something as a precautionary step for a lot of companies is we no longer show them here. We show them all on the machine definition side. So again, you can't come in here, post out, and actually click anything. We've streamlined it to make it easy and make sure there's no errors. Awesome. Any other questions outside of that? Yeah, Matt, you're right. Like we were talking before, you do have the call 0088, right? So there isn't really, honestly, I see that your question is, his question is collision verification without running machine sim? Well, you don't actually have to play your machine sim for collision detection. So I think a lot of people think you do, but if you go in and you say simulate with machine, and in this case, I don't have a machine, so I can't do collision detection. But the very first thing this will do if you're running machine collision, let's do it on this part here. Since, let's add a machine to this. Give me a quick sec. And what do we got here? I know we had a UMC in here, so actually this is a 3-axis toolpath. We'll be all right. We'll throw it on the old Haas. And I am going to have to switch over to a different Haas machine. We'll use the default Autodesk post here. There we go. So there's our part. Again, with the collision detection, if we go in and simulate with machine, I don't actually have to hit play here to simulate it. What you're seeing up here at the top is it's automatically verifying everything in the background, right? But as you can see is I didn't actually run the part through for collision detection. And if there was an issue, I can also go up here to the top and look at the issues, right? So there is no warnings, there is no issues, so forth and so on. You could actually say to stop on warnings and errors. I think a lot of people forget that there's these additional things if you wanted to go ahead and hit play and walk through it. So again, as if we were to take all of our tool paths here and run them through machine simulation, hopefully it actually causes a problem. And as you can see right there, I don't really need to run this because it's automatically telling me that there is no verification issues, right? So if I went to my issues list, nothing. No warnings, no problems whatsoever. And then we can actually look at the NC code as well. This machine does not have a post. And I think a lot of people overlook this stuff as well. So again, if we went back to our machine with the post, however, we're not going to actually be able to do anything with it. So we would have to take this much further, select a different machine, remove all of our properties, and we'll go ahead and select a different machine. Or I'm going to anger Fusion and we may have to take a break. Fingers crossed, guys. May the Autodesk angels be with us. Any other questions in the meantime while that goes through? See people bouncing in and bouncing out. Coming down to the wire, 8 minutes left. If we have to go over, we will go over. Obviously, I want you guys to be able to get these questions in. We always say, feel free to ask the questions because somebody else may have the answer, which sometimes the answer is better than what I can give you right away. Or somebody else might have the same question that watches this video at a later date so that you guys can stay up to date and get that information as well as they can get that information. Of course, if you guys have learned something new or saw something you like, don't forget to hit the like button, leave a comment, subscribe to the channel. So let's get back to Fusion here now that I've restarted it. So again, we're going to go ahead and pull that machine out. And we're going to select our new machine. And now we are going to actually put this onto a machine. That error I'm getting there is because that machine does not reside inside of my team. And there's our part. Let's go ahead and get that moved over. And again, if we were to go in and simulate this with machine, because of our post tie to our machine, we could actually go in and look at the G code as well. So I think a lot of people overlook the fact that you can walk through your G code inside of Fusion the same as you can in Complete. So if we were to go ahead and hit play here, you could see the G code running in real time as we walk through it. And as what was asked before is we do have that ability to look at our errors. There's no errors, there's no issues. It's automatically cycled through that right off the start. So for some of you out there, you may not know this. The idea is with the ability to calculate your stock on the fly, it helps with all of this stuff. So that sometimes you have those toolpaths that take a little bit longer because of that. But yeah, hey, there you go, Matt. I taught Matt something new. He taught me something new last week about using trace for broaching. I used to always use drilling cycles. That was my way to go about it. But the trace technique is wicked smart because then you can back your tool off. But yep, so you have that ability to go in, see your G code. And one nice thing about the way that works too is because if you're somebody that turns on all of your toolpath, you could go to specific points in your toolpath and you can see how I jumped over to that location. It's also jumped to that location in my G code. So if you're running this at the machine, you can go ahead and go to a specific line if you error out at your machine, and you can see why it's actually erroring out. So you should be able to turn that on up at the top, or I'm showing you something that I shouldn't be showing you, to which I'll probably get yelled at for, but it's not the first time or the last time. But up here at the top under the information tab, you should see G code. Seeing how it doesn't say preview on it anywhere, you all should have it. But yep. This is what happens when people send me stuff. They're like, hey, I'm having an error on this line. And if we built your machine model, I have a copy of your machine model. Usually if you send me a part, your machine model comes through too. I can run it through and see everything in real time. Any other questions outside of that? Winding down. So, Deep Thinker's question is it possible to add information in for safe tool locations for certain operations? So we have added that in quite a bit for people. We actually just put in a checkbox and we call it a large tool kind of maneuver. And with a large tool, it will move, say, your table out of the way, bring it all the way up above machine home, and then over and then back down to your actual tool change location. After your tool change, if it's a large tool, then it would also retract back up. So it looks like we have another question. Yeah, so unless you're on, and I may be wrong on this, is if you're on like an educational license or something like at a high school, I know there was like, back in the day, there was like Chromebook versions. All of your stuff is actually calculated local. So I think a lot of people confuse the idea. Like, it is not actually a cloud-based software. It uses the cloud. It's a hybrid. It's a desktop install that uses the cloud for data storage. So your toolpaths are all calculated locally, which you are technically limited by your computer's performance more than anything. No. So actually, none of the toolpaths are actually calculated out in the cloud. If you were to dive into other parts of Fusion like generative design and simulation, these are all actually sent out and calculated on something else. So yeah, I get that question a bunch. Multi-core, right? So I am running, I think, 18 cores, 20 cores on my computer. And a lot of times when I calculate these toolpaths, what happens is I'm only running on 1 or 2 cores. And if you think about it, the reason for that is just like your tool moves in a single line or a single lane, it really doesn't need a lot of cores. What it needs is fast cores. But if you were to go out and calculate multiple things all at once, and this is a good example of this, let me pull up Task Manager here real quick. And let's see if I could show you guys my performance on my computer. And we are going to show, let's see. Give me 1 sec. We want to look at this in a different way. So a lot of people always ask me about this is I have quite a few cores of processing, right? And the idea is when you guys go out and run a toolpath, it's not actually going to use all cores possible, right? So as you can see, some of my cores are doing stuff, some are not. So I'm going to slide this over here real quick so I can pull it back up. But if I take all these toolpaths and hit regenerate, and I get back to my resources quick enough, what you're going to see is some of these will start to calculate, and some of them won't actually fluctuate at all, right? So again, that was pretty quick. But overall, we're not running on all cores simultaneously. And it's because it's kind of like a road. You know, I tell people it's like a highway. If you have 1 lane and 1 car, that is more or less 1 toolpath. Now, sometimes you can use a couple of a couple of cores if you're calculating stock in the background. But until you have multiple lanes running, then you're still stuck kind of limited to 1 or 2 cores at a max, right? So when people ask me for computer recommendations, very rarely do I tell them to go get an i9, right? Or, you know, like the what is it, the 7900, 8900 series CPU, I always recommend an i7, and even in some cases an i5 does wonders. Now, if you're like me, and if you see running OBS Studio streaming to YouTube while running Discord and a million other applications, more cores tends to actually help out quite a bit because, again, as we're juggling multiple workloads, calculating a toolpath is a single workload. Calculating multiple toolpaths is multiple workloads, right? So you would be limited in some cases, but whenever you do things like rest machining is a huge one because you can't calculate the next one until the toolpath before it is calculated. So again, even if you had 100 cores, and I think we've all seen this, is somebody buys that Threadripper CPU thinking it's going to be the best thing ever, and you gain absolutely zero performance, if not worse performance, because that was designed for a lot of workloads. You're not going to send 100 toolpaths at once through a computer. Cool. Any other questions? I know that was a little bit of a rant, but hopefully that clears some things up for a lot of you. We are at the top of the hour, and I do got to do the exit intro as always. And why you guys wait until now to ask the questions, I don't know, but let's do this. But before I do the old exit intro, so again, it's the Marine Corps' birthday. Yours truly is a Marine, was a Marine, is a retired Marine. I don't know how you would go about approaching that. I am also a veteran. And if you guys love this content, by all means, it's the Marine Corps' birthday on Sunday. I do not plan to probably be upright for the most part. But if you want to contribute to my fun on Sunday and Monday for Veterans Day, feel free to go ahead and buy me a beer whenever you get a chance if you enjoyed this content. Now, if you don't enjoy this content, by all means, guys, go ahead and tell me with a comment down below what you didn't like so that I can do better to make this content much more to you guys. As always, you guys, it's not what you know, it's who you know. You know Fusion Phil over here at jitcadcam. Feel free to message me anytime with any questions you have. And as always, it's 5 o'clock somewhere on a Friday. So go out, have a great rest of your weekend.